Welcome to this video. Starting from March 2018, the Trace32 tools can be used to prove modified condition and decision coverage based on real-time trace recording, which doesn't require any instrumentation of the target code. To prove MCDC coverage based on trace data, a comprehensive analysis of all decisions and its corresponding conditions is required. The analysis requires that the structure and the position of all decisions within the source code is known to the tool. This means that additional information about the source code structure is required. This is currently not part of the debug information generated by the compiler. Lauterbach provides the T32 cast command line tool for this purpose, which analyzes the C or C++ source code. As a result, the information on the decision structure required for MCDC coverage analysis is generated for each source code file and stored in a so-called ECA file. ECA files are stored in the same directories as their corresponding source files by default. Consequently, the build process must be adjusted in order to allow this information to be generated. The T32 cast command line tool is compiler independent, and it can be easily integrated into existing build environments. This, for instance, is a simple makefile example where the ECA files are generated. In order to clearly identify the outcome of a condition at object code level in the trace recording, it is required that each condition in the source code is represented at object code level by a conditional jump or by a conditional instruction and not by an arithmetic representation of the condition. Thus, it must be ensured that the compiler generates the object code in such a way that it fits this requirement, for example, by disabling optimizations. We use in this video a Trace32 version of March 2018 with a Trace32 Power Review for PowerPC and a PowerDebug Pro together with a PowerTrace 2 connected to a Bolero 3M board with an MPC 5646C processor. Let's consider the following example code. I will start the program execution by pushing the Go button. The execution is stopped at the breakpoint set at the end of the run coverage demo function. The trace recording is automatically started with the program execution and stopped when the target is stopped. I will then open the CAD coverage configuration window by selecting the Trace32 menu CAV, then Configuration. The MCDC CAD coverage criteria must be selected using the source metric pull-down menu from the coverage configuration window. By default, the ECA files needed for the MCDC coverage analysis are automatically loaded when needed, but they can also be loaded in advance. This can easily be done by pushing the Touch All button from the sample ECA list window. As you can see, the ECA files previously generated for the coverage.c and main.c source files using the T32 cast tool have been loaded. Trace32 uses a CAD coverage database to collect valid trace recordings that should be analyzed. Push the Add button to transfer the current trace data to this database. The coverage results can be displayed at function level by pushing the ListFunc button from the coverage configuration window. Trace32 uses the following tags for the MCDC coverage analysis. Statement plus MCDC if a function is completely covered, or incomplete if MCDC coverage is not achieved. The percentage of achieved MCDC coverage is additionally displayed for each function. The following function, for example, achieved 85%. By doing a double-click on the function name, a source listing view will be opened and shows more details for the single source code lines. As you can see, the condition at line 304 did not achieve MCDC coverage. This function is actually called from the code below. The decision here is A or B and C with following truth table. To achieve MCDC coverage, the following test vectors are necessary. However, during the first run, we have only executed these 3 test vectors. This is why the measured code coverage was not sufficient to achieve MCDC coverage for our decision. Let's start the program execution again. We stop one more time at the end of the run coverage demo function. The executed code is, however, a little bit different from the previous run because of the tick variable. Let's add the trace data to the coverage database now using the menu gov, then add trace buffer. As you can see, the test vector necessary for MCDC coverage have been now executed and we have a 100% coverage for our function. Are you interested? Find more details on MCDC code coverage in this document. But of course, Trace32 has more to offer. Please refer to our other videos on this topic. Thanks for watching.